Hello everyone, my name's Rob Moore and I'm a lead consultant with Redify. I've been using pull requests over the last couple of years across a range of open source projects, both some personal ones and also some as part of an organisation that I'm involved with called TestStack, but also a range of other ones that I've put some changes to here and there as well. I've also used it on all of the commercial projects that I work on day to day. Now your first question might be, what is a pull request? Well, those of you who are familiar with open source and in particular GitHub are probably aware of them. Now they were created by GitHub and popularized certainly by GitHub as a way of providing some automation, visibility and social interaction around the merging of software changes. And it replaces the old school notion of emailing patch files to each other. Now let's take a look at a simple pull request workflow. Say you've got some sort of repository, in this case one on GitHub. Now, you probably don't have access to that repository, but what you can do is you can fork that repository to your own copy. And from there you can do what you would normally do and clone it to your local file system. And from there you can, make commits and changes, and eventually you might push those changes up to your fork. This is where the pull request workflow starts. You create a pull request from your fork into the main repository, and this basically tells anyone that has write access to that repository that you want to merge some changes in. So, let's see a pull request in action. Now, this is a pull request that I received last week on one of my open source projects. We can see here, it's got a pull request number, it's got a title, and it's got a description here. And there's the person that created the pull request. I can click through and see their profile if I want to. And initially they had 2 commits here, and I can click on the commits to see the diff. Now, if I click on this other tab here, I can actually see all of the commits that make up the pull request. And we can see here that there's actually another 2 that are in there from the initial ones. And I'll talk about them in a moment. I can also see the overall diff, which shows me the complete set of changes that would get merged into my repository if I click on the merge button. Now, it's worth noting that this is just the visualization of pull requests that GitHub uses. All of the different tooling, I should say, are slightly different, but they all generally have the same kind of concepts in them. Now, if we scroll down here, we can see a few other things. There's this user here, Emma Collective Team City, that talks about a continuous integration build and then the fact that it was successful. This demonstrates the build server integration as part of GitHub. Now, my Team City server detects automatically that a pull request has been submitted to my open source project, and then it runs the CI build against the commits. And we can see here that there's actually a green tick against this commit because that commit passed the CI build, and that tells me that the code compiles and all of the unit tests passed. If I scroll down, we can see I've got a comment here just acknowledging the fact that there's a pull request, and then I've got 2 comment streams against outdated diffs. Now the reason why they're outdated is that since I've commented on the code, that code has been changed by the contributor. And GitHub basically detected that these comments probably aren't relevant anymore. But I can see what the comments were, and in this case there's a specific line of code that I've commented on and just said, hey, there might be some HTML unescaping issues with this code, here's a suggested workaround. The contributors then said, no, that doesn't actually work, but I figured out another way around it, and then I've just said, cool, that looks good. And we can see here that he's submitted another commit. And again, the CI build automatically ran on it and passed. And then finally, I've just got a comment here saying, hey, there's some other stuff there. If you get rid of that, I'm happy with the pull request. He submitted another commit. The CI build ran again and passed. And then eventually, I merged the pull request. Now, this is a really nice example because it just shows a number of the different things that are involved with pull requests. So my assertion is that pull requests form the bedrock of modern open source software development. And this is because I've noticed a trend where increasingly open source software projects are moving to platforms that have pull requests in them, platforms like GitHub and Bitbucket, and moving away from platforms like Google Code and SourceForge that don't have them. And increasingly, when I look at open source software, I'm seeing that pull requests are being used, not only by the contributors, but increasingly by the actual maintainers of the software as well. Now, to try to understand why this is, it's probably worth looking at the behaviors that pull requests kind of result in. Firstly, if we look at contributors, typically these are going to be random for third parties. Now, pull requests make it really easy for them to contribute to the software, and it's really effective at getting their changes merged in. It's easy because all they have to do really is fork the repository, push some commits, click on a single button, and you pretty much have a pull request. Now, the contextual conversations that you get, like I demonstrated, against, and these are threaded conversations against a single line of code, they make it really easy for contributors because it's so much easier for them to understand the comments that are being made by the maintainers for things that they're suggesting be fixed, since they're against specific lines of code. So it's just another thing that makes it really easy for contributors. Another really interesting thing, when the maintainers of an open source project start to use pull requests themselves, contributors can actually subscribe to notifications when the pull requests are created on a project. So for instance, at the moment, I'm using a project called Ionic Framework to do mobile app development. And I've subscribed to their repository, so I get notifications every single time that the contributors are making pull requests. And this is awesome because it allows me to keep track of all of the changes that I'm interested that make it into the code base. Now, if we look at things from a maintainer perspective, the fact that pull requests make it easier for contributors means it's much more likely that they're going to get contributions to their projects. Now, as someone that has a number of open source projects, this is really great. And there's a couple of things in particular that come to mind here. The first is, whenever someone creates a pull request for one of my projects, it absolutely makes my day, because someone's thought that some code that I've put out there is good enough and useful enough to them that they wanted to add something to it. But the other thing is, if there's a whole heap of different people contributing to and improving and building on a code base, it makes it much easier for a maintainer to split their time across different projects, because it's not just them working on the code base. Now, the contextual conversations make it really easy for maintainers as well, because it means that they're able to more easily communicate with a contributor what changes need to be made to the code that's been submitted. This makes it easier for the maintainers to get the code ready to be merged. And what this means at the end of the day is it's less likely that the maintainers are going to have to go to extra effort and pull the code in and make changes themselves. It's much more likely that the maintainers can simply click on a button and then the code automatically appears in their repository. Now, one thing I've noticed is that pull requests seem to foster a much more collaborative community around a code base. There's a lot of discussions going on, there's a lot of people contributing code. It just seems to be a lot more collaborative. Now, if the maintainers are using pull requests for all of their code, the other thing it gives them is it gives them the ability to be able to make sure all of the code is reviewed by at least one person before it goes into the code base. And then you get all of the advantages that you normally get with code reviews. There's one other really cool thing that you can do with pull requests, and that's to coordinate distributed work in progress. So you can imagine an open source project potentially or even likely has people from all over the world working on it. So if you've got a particularly complex change that's going to take a number of people working on it before it's okay enough to get into the code base, what you can do is you start off by creating a branch, in this case feature X, and then you just open a pull request as the first thing you do. Then from there, different contributors can submit pull requests to the feature X branch. So say we've got Rob here, he creates a branch in his fork, he makes a couple of commits, he opens a pull request into the feature X branch. Now at this point, we've actually got nested pull requests. Then we might have a user Matt. He creates a branch in his fork, he makes a commit, and he opens a pull request into feature X as well. Now eventually those two pull requests will get merged, and those 3 commits will appear in the feature X branch. And then when everything's okay, that feature X branch pull request can be merged, and those 3 commits will make their way into the master branch. So in summary, what pull requests do is they lower the barrier of entry for everyone when it comes to open source software. And it's just really good. I think it's really improved and helped open source software as a whole. So if you kind of stop thinking about open source for a minute and start thinking about the projects you're working on day to day, you might initially think, well, we don't need PRs. We've got closed source, which is the opposite of open source. Everyone has access to the repository. We're all co-located, so we don't care about the remote work stuff. And we've got existing code review processes, so we don't need the code review side of it. Well, to be honest, I disagree with all of these. Now let's explore why. The first one is that pull requests allow you to increase quality through code reviews. Now I just said, we have an existing code review process, but to be honest with you, every organization that I've been in that has some sort of code review process, it's always been fairly ad hoc. And it generally ends up needing the person making the change to be proactive to ensure that the change gets code reviewed. And if you throw deadlines into the mix, then it soon starts falling over, and quite often you start getting commits put into the code base that aren't reviewed by anyone. In contrast though, if you look at a pull request, someone has to click on a merge button. It's a very explicit action. And in doing so, that person is taking responsibility for that code going into the code base. Now, again, I don't know about you, but for me, if I'm going to click on that button, I'm going to want to at least glance through the diff to make sure that that code's okay before I'm responsible for that code being in the code base. And what this means is, regardless of any other process that the team kind of forms around code reviews and pull requests, and in general, from what I've seen, you'll get quite a number of pairs of eyes on most PRs. Then what it means is that at the very least, every pull request that's created will have one other set of eyes on it. So you're basically ensuring that you definitely have code reviews. And then you get all of the advantages of code reviews, like ensuring consistency, maintenance, and quality of the code base. Now the contextual conversations really help here as well, because when there are problems, it's much more easy for the different people involved to have a conversation because it's against the context of a particular line of code. It makes it easy for the changes to be made. Now, one other thing I've noticed is in the past, before pull requests, was if someone's looking at a history of changes and they notice something minor in one of the commits, like white space or variable naming, or code that could be a bit clearer maybe, then often inertia seemed to be used as an excuse to not make the changes. So you might say, oh, well, we've got a lot of deadlines coming up. The changes are pretty minor. I'll let this one slide. The problem with that though is over time, all of those little minor changes start to add up and form quite a bit of technical debt. If you contrast this with pull requests, however, the pull request hasn't made its way into the code base yet. So when someone notices those minor things, it's much more likely that the changes will actually be made to that code before it gets merged in. There isn't as much momentum then. There's not as much inertia. It's so much easier for it to happen. And from what I've seen, it does happen. Now, I already demonstrated the ability to integrate a build server with your pull requests. Now, what this allows you to do is, when you do it, is to increase the quality by reducing the number of build failures, because when you merge the pull request, it's very unlikely to break the build. So you've now got a consistent amount of kind of quality in the code base by reducing the build failures. One of the other things that pull requests are really good for is supporting new developers. Now, pull requests lower the barrier of entry to learning about a code base. So say there's a new developer, they have to do a new feature. They can go and look at the pull request and find one with a similar kind of feature. They can look at the diff and they can see how it's been implemented. This is so much easier than looking back through the log and trying to look at all the disparate commits and actually find one that is relevant. What they can then do once they've implemented something is have the confidence to be able to raise a risk-free PR. So ordinarily, they might have to make sure 100% that the code's okay before they push it in. Whereas with a pull request, they can just create the pull request. Other people in the team are going to review that pull request, and then the new developer, they're going to learn, which things needed to be improved. Again, the contextual conversations really help here because it's much more easy for the new developers to understand the comments that are being made because they're in context of the code itself. And the things that the new developer is going to learn in this instance is going to be founded in practical application because the developer was actually making a practical change at the time. So it means it's much more likely that they're going to remember these things that have come up. Overall, from what I've seen, pull requests allow you to have a smaller ramp-up time for new developers. Now, on a related note, it also seems to be really good at upskilling junior developers. For the same reasons why it supports new developers, it helps the more junior developers to learn about the code base and to upskill themselves. But the other thing that it does is it provides a more level playing field. So if you think about a scenario where there's a senior developer, he's written some code, and then he grabs one of the junior developers to review the code. Now that's a really good learning opportunity. But the problem is it's quite intimidating sitting next to a more senior developer, and quite often you'll probably find that the junior developers are less likely to point out things that they see in the code that they're not sure about. Whereas with a pull request, it's a lot less confrontational, a lot less personal. If there's a bit of code that the junior developer isn't quite sure about, or they don't understand how it works, they're much more likely to actually comment on that line of code and ask about it. And then once they've done that, they're going to learn something from that, or possibly even they've identified a problem in the code. And that's really good for everyone involved. Now, pull requests are pull-based, right? They're not push-based, and as such, they're asynchronous. Now, in this day and age, I'm seeing a much higher propensity for companies to have remote work. So you might not all be co-located. Companies might be outsourcing to another country, or the more progressive companies might be allowing their developers to work from home. Or they might just have a distributed workforce, maybe across a country or even across the world. So this asynchronous nature of pull requests supports that by making it much easier to do code reviews. So for instance, you might go home after having put a pull request up, and then someone on the other side of the world could be reviewing that pull request. And again, the contextual conversations really help here, because it's so much easier to communicate in the context of the actual code. On a related note, you can actually avoid some context switching overhead with pull requests as well. Because if you put a pull request up for a fairly minor feature, you then don't have to go and interrupt someone that might be in the middle of some really complex code and then pull them out of that and then get them in the frame of mind for the pull request, which invokes a fairly large context switching overhead. With pull requests, you don't have to do that. You can move on to something else, and then when the other person has finished what they're doing, they can come and review the pull request. Pull requests also allow you to more easily separate changes that you're working on. So let's see this scenario here. Now, if you haven't seen command line git before, this is kind of what it looks like. Hopefully it's fairly explanatory. You check out a branch, feature W, you add some commits, and then you find a bug. Maybe it's a really simple bug, like a one-line fix or something like that. Ordinarily, what you might do is just fix it and then do a commit. But then the bug fix commit is kind of intertwined with all of these other feature commits, and that can be a bit confusing later on when you're looking through the history. With pull requests, what you can do is you can say, well, okay, I'm going to check out the master branch, and from there I'm going to check out a new branch called bugz. I'm going to do a commit to fix the bug. I'm going to push it to the remote repository, and then I'm going to click on a couple of buttons to create a pull request there. At that point, you can basically forget about that bug, because at some point someone's going to review it, make sure it's okay, and merge it in. So then all you need to do is to check out the My Feature branch again, and then continue doing the work you were doing previously. Now, one of the other things that pull requests can facilitate is a reduction in developer feedback cycles. So if a developer's working on quite a complex piece of work, maybe a big change, then they can create an early pull request with some of their work in progress. They can put it up, they can annotate it that it's work in progress so people don't merge it, and then they can allow the rest of the team to start to give feedback on the change that they've done. Now that feedback might be that they should completely change the direction of how they're implementing it. If they get that feedback early, it's a lot easier to make that drastic change. Whereas if you think about if they had instead got that feedback when they completely finished the feature, then either they're going to say, well look, I don't have time to completely re-implement it, let's just put this in, at which point you've got some technical debt. Or alternatively, they might actually go and make the change, but the change would be quite costly, it takes a lot longer. So by supporting work in progress feedback, pull requests are allowing us to reduce our feedback cycles and be a lot more clever and reduce a lot of our potential waste. Similarly, technical spikes can actually be developed in the open by using pull requests, and where you can start getting feedback from your team. Now, if you're a large organization and you've got a lot of developers, maybe in disparate teams with conflicting priorities, making a lot of changes to a code base, it's often hard to maintain standards and consistency in the code base and to maintain the vision, the long-term vision of that code. Now, in this sort of situation, an open source model is actually quite helpful. Say you've got a product A code base and a product B code base. And the product A code base has a core team, product A core team, and product B code base has a product B core team. Say the product B core team is working on a project that requires them to change the product A code base in some way. They can fork the code base, make their commits, and create a pull request. And then someone from the product A core team can review that pull request and make sure that it meets the standards, the consistency, and the vision of the code. They can have some interactions via contextual conversations, and eventually the code will be okay, and the product A core team will merge the pull request in. So if you're in a larger organization, it's definitely worth considering this kind of model, because I think it's a really nice fit for that kind of problem. Now, in summary, pull requests and specifically introducing them to a team has been the most effective change that I've seen that's improved code quality. So I absolutely recommend them for commercial software development. But, nothing's perfect, right? It can't be a silver bullet. And yeah, there are definitely some things that you need to watch out for. Now, the first one is something called bike shedding. Bike shedding is actually based on some management theory from the 1950s, but it was first introduced in a software context in 1999 by someone from FreeBSD. Basically what it says is that if a particular code change is very simple, something that a lot of people can understand, then you're much more likely to get people commenting on that change and providing their opinion. Whereas if you have a really complex change that's hard for people to keep in their heads and understand, you're a lot less likely to get comments and feedback and opinions on it. People will generally just assume that someone smarter than them has looked through it and understood it. Now, I've got an example here on this slide. We've got a change to an open source project on 2 changed files, which has 3 additions and 3 deletions. We're just changing him to them in the first file and he to they in the second. Now, this very, very simple change resulted in 226 comments. Now, clearly this is very extreme, and if you look at an organisation, it's very unlikely that you're going to have something that extreme. But to a much smaller extent, this bike shedding type of thing can happen. So it's just something to keep an eye out for, and when it does happen, to just curb it. So this quote here is from the person that kind of, brought bike shedding, the term, to software, and he says that just because you're capable of building a bike shed does not mean you should stop others from building one, just because you don't like the colour they plan to paint it. You need not argue about every little feature just because you know enough to do so. The amount of noise generated by a change is inversely proportional to the complexity of the change. Now, another kind of related note is around pickiness. Now, if you have someone in the team that's really, really picky and they're always kind of pointing out heaps of different things in every single pull request that gets created, you might start to have an unhealthy behaviour emerge where people try to avoid that person reviewing their pull request by asking other people to review it. Now, this is an unhealthy behaviour, and if it happens, it's just something to kind of note and to try to deal with. Now, when a pull request is created, there's quite likely to be two different styles of comments. One of them is going to be things that are absolutely essential to change, things that will break if you don't change them. So they have to; those comments have to be responded to before the pull request can be merged. But then the other style of comments are going to be quite minor things like, this code could be a bit clearer, this white space isn't correct, this variable name could be better, stuff like that. Now, quite often what I see is that sometimes it's important to just let the minor changes be dealt with in a separate PR and to trust the developer to create that PR and do it, and then just merge the bulk of the pull request in with the bulk of the changes. And then that way, the value that pull request is providing to the code base is merged in sooner, and it's less likely to get conflicted. One of the things that can happen, and it's kind of a natural thing that kind of happens with programmers, but a particularly controversial change, or maybe a change someone doesn't quite understand, it takes a lot of kind of back and forth to get on the same page, can end up in this sort of situation like we see on the slide, where there's a crazy amount of comments. Now, at some point, in particular if the person's sitting right next to you, or they're on the other end of a Skype video call, this becomes way less efficient than just talking it out for a couple of minutes and getting on the same page. So when you see this sort of thing emerge, just notice the fact it's happening and maybe say, hey, we should go take this one offline, figure it out, and then we can comment back on the PR so that anyone else that's following the conversation can see the resolution. Really unhealthy behaviour that pull requests often result in is a lack of respect. Now, it's possible that the lack of respect is quite deliberate, in which case the pull requests are helping because they're visualizing the particular problem. You can, notice that it's happening and then deal with it. But sometimes it's not deliberate. As developers, we often have very strong reactions to code. We start to use these kind of emotive words like code smell and, awful and rubbish and stuff like that. Now, whilst the comments aren't necessarily meant with malice, if you think about it from the perspective of the person that's created the pull request, that can be quite hurtful. And they start to kind of break down some of the team collaborative dynamic. So in general, I try to say avoid emotive phrases like these. One tip that I do have that's worked quite well for me is I often try to express my comments as questions. So I might say, have you thought about what it might be like if you try it in this way? Or, do you think this one would be better if we did this? because it's a question, I'm interacting with the contributor and kind of engaging them in a collaborative conversation, and together we can realize the best way to do something. Now, if you're in a situation in a really large organization, there's a lot of developers committing on a code base, maybe disparate teams, the kind of thing I mentioned before about the open source software model, and you don't have a core team, you're often going to end up in situations where pull requests will constantly get conflicted because there's so much change going on and there's little cohesion in the way that the teams are working together to merge the PRs. It's also possible that when this happens, that people will then start to work with other members in their team to merge the PRs with very little inspection, or even worse, developers might start merging their own PRs. Now, one of the other problems you can see is that if the PRs are actually reviewed and there's comments there, then quite often people will cite, the priority of their project and say they don't have time to resolve the comments and it needs to be merged anyway. And then what this means is that there's kind of a build-up of technical debt, and the consistency in the code base isn't great, and all of the other problems that you normally see in this sort of scenario. Now, that open source software type model that I talked about before is one solution to this type of problem. The thing is, this behavior would exist regardless of pull requests. It's just that the pull requests are actually helping us by visualizing the problem. So once you visualize the problem, you can then start to try to address it. One of the biggest problems that I find with pull requests is when people create enormous pull requests. Now, they're bad in a number of different ways. They take longer to get up because the person is spending a long time doing the implementation. And so it means that it's a longer period of time for the value that they're creating for the code base to be merged in. They're harder to review for the reasons I talked about with bike shedding previously, which means they're also more likely to be wrong because they're going to be less thoroughly reviewed, and it's more likely there's going to be errors in there that get their way through. They also become harder to integrate because it's much more likely that the bigger pull requests are going to get conflicted as all of the smaller pull requests around them get merged. So in general, big PRs are something to avoid. One of the other things that we have to deal with the pull request tooling is bad diff UIs. We can see in the top right here, we've got one from Bitbucket. It's showing a file rename with no other changes as a block of red and a block of green. Really unhelpful, particularly for commits that have a lot of renames. And then the other examples on the screen here are some examples from GitHub, and they're not too great either. It is hard to understand what the actual change is. This one's fairly easy to get around though, because all you need to do is basically pull the code locally and use your local diff viewer. So look, these things are something to be wary of, but in general they're fairly easy to deal with. And for all of the behavioural issues, pull requests often help to actually visualize the problems, and then once you visualize them, they're easy to address. Well, maybe not easy, but they're able to be addressed. So, hopefully, I've got you convinced pull requests are really cool. Now, as I said at the start of the slide, I've been using pull requests for the last 2 years, so there are a range of tips that I have for people that are getting started to try to make them work more smoothly. The first one is about investing in the future. So make sure you have good commit hygiene. Have small focused commits with really good descriptions. This makes it easier when you're looking back in history and you're trying to find why a particular change was made or where it's made, or you're trying to do like a git blame or something. This just makes it easier. It's also important to retain metadata when merging pull requests. So making a separate merge commit with the pull request number in the description, and that way you can go and refer to a pull request later, and it also groups together the commits from that pull request so you can kind of see them together. I should note that retaining the metadata happens automatically when you click the merge button on all of the PR tooling. Keeping pull requests focused is important too. It's more likely that your pull request is going to be small But also, if you can imagine a situation where one pull request has 4 sets of logical changes in it, maybe 3 of them are fine, but the 4th one has some sort of problem in that has to be resolved before the PR can get merged. Well, in that sort of scenario, all 4 of your changes are being held up by that one little problem. Whereas if you raised 4 separate pull requests, 3 of them could have gotten merged in while the other one was waiting. It's kind of common sense, but having a good branch name, a good PR name, and a good PR description helps the reviewers to understand what it is that you're trying to put into the code base. Now, in terms of PR hygiene, I've already covered this, but keep your PR small. Putting frequent PRs in is really good as well. Small frequent PRs means there's a general flow that the team's going to get used to, and it results in a really nice kind of amount of value going to the code base constantly. Deleting remote branches when they've been merged is also a good practice. It makes it a lot less cluttered in the remote repository and makes it easier to see which branches are currently in play. Now, the whole thing about pull requests is we're trying to get the team to collaborate together. So subscribe to notifications, get an email every time someone creates a PR so you can see the PRs that you're interested in and go and have a review of them. And make sure that you're regularly reviewing and merging your pull requests. You know, maybe in between features you've got a spare 5-10 minutes, go and take a look at the PRs, review them, merge them in. In general, I prefer to have 1 PR per person. That makes it a lot easier to manage, it's a bit less confusing, and then the person has full control over their branch, and they can do things like rebasing, which is changing the history, to clean up the PR so that at the end of the day, our commit history in the main repository is a lot cleaner. If you are in a situation though where you are working, multiple people working on one feature, then what I generally advise is to pair at the start until you get to the point where the integration happens, and then from there all of the other work should be able to be done in parallel. Or alternatively, you can do a nested PR type approach like I looked at earlier in the presentation. So at the end of the day, we're trying to foster collaboration. We're trying to foster a good team dynamic. So act as a team. Be nice to each other. Avoid those emotive phrases. And look, call out awesome work. If you see something that you really like, or something impressive in the code, call it out. Say, nice work. You know, that was awesome. If you see anything in a pull request that you're not sure about, just ask a question. It's really easy to do. And you know, like you might learn something. Alternatively, you might pick out something that's actually wrong in the code base. Or also, you might pick up something that, you know, if you didn't understand what that code did, other people might be in the same boat. So then you've picked up something that should be changed for the future maintainability of the software so the code's more readable. If your PR isn't urgent, don't interrupt people. We don't want to get that context switching overhead. And I mean, this is common programmer etiquette, but if you're about to do major work or some sort of huge refactor, discuss it with the team first before raising a surprise PR. And at the end of the day, one of the most important things is to just have fun. Software is a really serious business, but that doesn't mean that we can't have fun. At the end of the day, this is what we do for our day job. So if we can't have fun, what's the point in going into work? And, you know, the other thing is that having fun in the pull requests, it kind of helps to foster that nice team dynamic. So these tips that I've been through, they're going to help to make the PR workflow work more smoothly with your team. So hopefully I've kind of convinced you, hey, you know, when I go back to work on Thursday after the conference, I should go and use pull requests. But you might be thinking, well, how do I get started? Well, this is generally what I advise. The first one is to use Git. You can kind of get away with using Mercurial and Bitbucket, but pretty much most of the tooling out there is kind of focused on Git. most of the documentation, most of what people are talking about and writing about. Git is a really, really powerful source control system. I mean, if you're using something like a centralized one, like SVN for instance, then you can't use it. You have to move to a distributed source control. The other thing that's really important is to find someone that knows Git really well. This is important because the team, when they first start using branches, are possibly going to get a little bit confused. Once you know what's going on, it's really easy, but that initial kind of period of time can be quite confusing. So having someone that can walk over, take a look at the screen and say, oh yeah, you just forgot this, makes it so much smoother. In general, what I do when I introduce pull requests to a team is the first couple of weeks I'll spend actively reviewing and merging pull requests. This gets the team used to that kind of constant flow of pull requests. And then from there, I'll just kind of stop for a while. And typically, the team will self-organize into their own rhythm. There's inevitably going to be a pain for everyone at least once from large PRs. And when you see this start to happen, just let it happen. And then once they've been through all that pain, there's conflicts all the time, it takes them ages to get it merged. Just sit down with them, be a little bit retrospective, say, that looked a bit painful, what do you reckon happened there, how could we stop it happening in the future? In general, they're going to realize themselves that, next time I should have created a smaller PR. And that's good because if they make the realization, it's more likely it's going to be something permanently that they remember. In terms of tooling, there's obviously GitHub and GitHub's on-premise version, GitHub Enterprise. But you've also got some Atlassian tooling, Bitbucket, which is their hosted service, and Stash, which is their on-premise one, and GitLab. Now, the ironic thing is, the absolute best of breed that I found is Atlassian's Stash, because it's just awesome. The pull request workflow is really nice. Everything it does is really nice. But the ironic part is that Atlassian's Bitbucket is also the worst. It is really, really bad. At the end of the day though, any of these are going to have pull requests. It's going to be better if you've got something with pull requests. So you can still make Bitbucket work for you. A couple of other things. If you're using Stash or GitHub, then you can have the build server integration. And there's a project called Git Version that some people I know are currently working on. It's pretty cool. It allows you to inspect Git metadata to come up with a semantic version compatible version number for your software. But one of the other cool things they built into it is the ability to detect pull requests and create a version appropriate to the pull request. So look, apart from the fact that you should be using PRs for commercial development, there's really three main takeaways that I have from this talk. And that's that when you're using pull requests, you should be respectful, you should have fun, and dear God, please keep your PR small. And that's everything from me. Thank you.